Well, hey there, kiddos. Today we are going to talk about systems of inequalities. Everything that we have done to this point has been a system of equations, and so I've had x equal to number and y equal to number. Now we're going to be dealing with inequalities, so I'm going to have greater than or less than symbols in my inequalities and not equal signs. And so it's going to change how we approach the problem. Instead of using substitution, elimination, or graphing or to solve these and getting y and x, what we're actually going to do is we're going to graph. And our solution to a system of inequalities will be any point that falls inside the double shaded region. And when we graph one in just a minute, you'll see what I'm talking about. But a solution is any point that is inside the double shaded region. Or on a solid line. So if it's in the double shaded region, it's good. If it's on a solid line, then it's also part of the solution. So if you'll remember, when we're dealing with inequalities, we have these symbols. We have greater than and we have less than. So this is greater, this is less. And so when I'm graphing these kind of lines, if you remember, when I graph a greater than or a less than, if it's just greater or just less than, when I draw the line, I have to draw a dotted line, because points on the line don't count as a solution because they are not equal, because it doesn't have the or equal to part. If I have these kinds of symbols, greater than or equal to or less than or equal to, then instead of a dotted line, I get to put a solid line, because points on these lines do count as part of the solution because they are or equal to. So that little underline there underneath my symbol makes it an equal kind of thing, and so I have a solid line. Other things to remember: if my symbol is greater than, that means I am going to shade above the line. If my symbol is less than, that means I'm going to shade below the line. And this will all come back to you as soon as we graph one here in just a second. So let's actually practice some of this. Let's graph some systems of inequalities. Our solutions today are going to be graphs with shaded regions. They are not going to be ordered pairs like they have been with the systems we've done for the last 2 weeks. So here we go. Number one here. It says that, the first four ask us to solve by graphing and then name one point in the solution area. So the first thing we have to do before we can graph those is make sure that our equations are already written in slope-intercept form. So we have to solve for y equals. So you see both of my equations here need to say y equals. The top one's pretty simple. If I want this y by itself, I have to subtract 2x. So I get y is less than or equal to negative 2x, because I subtracted it, plus 4. Now the bottom one's going to take a little more work. So I have 2y plus x is greater than or equal to 8. You might need to write this smaller than I am because you're going to need the graph in a minute. So I want to subtract x from both sides. So I'm going to have 2y is greater than or equal to negative x plus 8. And then I have to divide everything by 2 so that y is by itself. So I have y is greater than or equal to. I don't have to flip the symbol because I divided by a positive. If you will remember, the rule says if you are dividing by a negative. So since I divided by a positive, I do not have to flip the symbol. So I'm going to leave it alone. Well, this becomes negative 1/2, because there's a 1 there, x plus 4. So now I have my equation. Y is greater than or equal to negative 1/2 x plus 4. So I'm going to erase my work here since it's taken over my graph. And I'm going to graph my lines. We're going to do them one at a time. So we'll do this first one. The y-intercept is 4, so it means I get to start right here at 4. And then my slope is negative 2, which means from here I got to go down 2 and over 1. And I can go down 2 and over 1. I can even go backwards like this, and then I'm going to connect those points with a line, and it's a solid line because it was or equal to. My little symbol is underlined. Now I have to talk about the shading. This is a less than symbol, and if you'll remember what we just wrote down, it says that less than we shade below, and here's how I know which direction is below. If you look at the y-intercept, less than the y-intercept would be this direction, so I have to shade in that direction for that line. So you want to shade it in, and you don't want to be chintzy with your shading here because we need to see where they overlap. You don't want to color in the whole thing because you don't want to waste your pencil or your ink, but you do want to make sure that it is shaded in enough that you can see that whole region is what gets shaded. Don't just kind of go like this and say you're done. Shade in the whole region. So now let's graph the other one. I'm going to switch colors. If you have other colors you can switch with, that would be good because it helps to see what's happening. So this next one, the y-intercept is also 4, so I have a point here. But this time my slope is -1/2. So that means I have to go down 1 and over 2 to get to my next point. Can even go backwards. And then I'm going to connect these points with a line. It's also a solid line because this was also or equal to. So now I have that line. This one happens to be greater than or equal to, which means I get to shade above the line. So if I start at the y-intercept, above would be everything up here. So now I have to shade all of this part. And if you will notice, because purple and blue, or blue and red make purple, this right here is where the red and the blue meet. And so this is my solution area, this little region right here between these two lines. Since I have solid lines, they're called boundary lines. Since my boundary lines are solid, they also count as part of the solution area, as does everything that is shaded. And so they've asked me, now that I've graphed it, to pick a point that's in the solution area. And since I colored really, really well, it's going to be very hard to pick a point in the solution area here. But I'm going to do my very best. I'll pick this point right here. And if I count my ordered pairs, it looks like that is going to be -2, +6. So my point in the solution area is -2, 6. That's not the point you have to pick. As long as you pick any point on the boundary lines here, because they're solid, or in the shaded region, you're good. So let's do the next one. So if you look at number 2, I've got y is less than 3. Well, that one is easy. It just says y. There's no x value in here. This is a HOI, which means it's a horizontal line. Y is at 3. So right here is where y is 3. And this says y is less than 3, which means when I draw my line, it has to be a dotted line because it doesn't have the little underline on the symbol. And if we're talking about less than, well, less than this line will be everything under here. So we have to color in all of this down here. Okay, now the next one, I've got to get y by itself. I have a little bit more room this time, but that's what we're going to do. I'm going to start by subtracting 8x. So I have -4y is less than -8x because I subtracted it plus 12. Now I have to divide everything by -4, and so now that rule applies. Now I have to turn my symbol. It now becomes greater than because I divided by a negative. And when I do -8 divided by -4, that makes +2x. And 12 divided by -4 is -3. So now I have my equation. I'm going to graph. So I'm going to start at -3. And my slope is +2, so I get to go up 2 and over 1. Up 2 and over 1. And then I can go down 2 and over 1. And I'm going to connect these with a line. And it's a dotted line again because it was just greater than. It's not or equal to. So we have another dotted line. So this time points on the line don't count. And I have to shade greater. You have to go with the final equation, not what you started with. So this is the equation I want to use to shade. And if I have to go greater, I have to shade everything above, which is everything on this side of the line. And so if you'll notice, here is your double shaded region. And unlike number 1, boundary lines don't count here because my boundary lines are dotted. But any point in here in this double shaded area will count. So let's grab a pen. Let's pick a point. This one right here looks like it's in the double shaded area, and that looks like it's -2, +2. So a point in the double shaded area is -2, 2. So I'm going to have you pause for just a second. I want you to solve both of these for y, and then I want you to graph the two lines. Don't worry about the shading. Let's graph them first, and then we'll talk about the shading. So pause and then come back and we'll talk about it. Okay, so I have my two lines. One of them is y is less than or equal to -x minus 2, and the other one is y is greater than -x minus 2. If you will notice, they have the same slope, same y-intercepts. They're going to end up in the same place. I have not connected my points yet because this one is going to be a solid line. This one is going to be a dotted line, and when you have that happen and they overlap, they are the same kind of line, the dotted line beats out the solid line. So this is going to end up being a dotted line because the dotted line wins even though they're the same line. But now I have to talk about shading. This top line gets shaded above. So everything above it gets shaded here. I just did that upside down. It is not shaded above, it is shaded below because that totally says less than. I apologize if I just screwed up your graph. However, you're going to see I really didn't mess it up as bad as you think I did. So it's -2, down 1 over 1, down 1 over 1. And it was a dotted line. I'm sorry that I cannot draw straight lines. Okay, less than means shade down here. The bottom one says greater than, which means I get to shade up here. And so since one is solid, one is dotted, I have a dashed line. One gets shaded below and one gets shaded above. My shaded regions never ever meet one another. They don't ever touch. And because I had one solid, one dotted line, remember points on dotted lines don't count. And so since I can't count the line either, this has no solution. There's no overlap whatsoever. Now, if both of these lines had been solid, then I would have solutions on the line and on the line only because they would overlap and meet there. But because I have one solid, one dotted, and my shaded parts don't meet each other, then I have no solution when I graph that. So let's look at number 4. Number 4 has 3 lines happening, and it's okay. We can do 3 lines. We're still going to have a overlapping shaded region. The first 2 lines are easy to graph. X is greater than 0. Well, this is a vux, so it means it's going to be a vertical line. And if where x equals 0, well, x is 0 right here, so it's a vertical line where x equals 0, which happens to be your y-axis. But it's a dotted line down your y-axis because your symbol is not underlined. And because it says x is greater than 0, then I have to shade everything greater than that, which is everything over here. And then I have to do the next one. So I have y is greater than 0. Well, that's the x-axis because y equals 0 along the x-axis. And again, I have a dotted line along my x-axis because my symbol's not underlined. And to be greater than that, I have to shade everything up here. So if those were my only 2 lines, my solution would be in quadrant 1 right here where the overlapping is. But now I have to deal with this bottom equation. I got to get y by itself by subtracting x. So I have y is less than negative x plus 6. Let's grab one more color here. I'm going to start at 6, and then my slope is negative, so I'm going to go down 1 over 1, down 1 over 1. And this is still not underlined, so it's still a dotted line. I'm going to draw a dotted line through here. So there's my line, and now I'm less than, so I have to shade everything less than that, which is going to be everything here. And if you will notice, this triangle right in here is where the 3 colors overlap. I have red, blue, and green in this little triangle. And that's where my solutions are. Not here where it's just red and blue. Not here where it's just blue and green. Not over here where it's red and green. It's got to be red, blue, and green all right there. And so that's where my solution is going to be. So if I grab a pen, let's see, here, right here, that's going to be a point that is in the triple shaded region, which happens to be the point 1, 1. That's going to be a solution, as would this point over here or this point right here. But you cannot include points on the lines for this. Boundary lines don't count because they're all dashed. So now number 5. Number 5 gives you the graph. And then they say, write me a system of inequalities for this. So we're going to take them one at a time. We're going to call this line 1. And we're going to call this line 2. So we're going to do number 1 first. And in order to write an equation or an inequality, I need to know M and B. So we're going to start with number 1. It looks like the y-intercept is right here at 3, so I know it's going to end up being plus 3. So that's my B. Now I've got to find another pretty point so I can do my slope. Well, there's another pretty point, and to get from here to here, I had to go down 1 over 1, which gives me a slope of -1. So that's a -1x. And if you look, and here's where you have to pay attention, find the double shaded part. It's the darker part of the graph. The double shaded part is above this line, which means I had to be greater. And I'm greater than or equal to because this is a solid line. So there's my inequality for this. I got the greater than because it's the double shaded part's above. I got the or equal to because it's a solid line. The negative x came because my slope was -1. I went down 1 and over 1. And the +3 is from my y-intercept of +3. So let's do the second one. So number 2, we'll start with the y-intercept again. This time the y-intercept is -3. It's at -3. And my slope, here's a pretty point and here's a pretty point. Well, I had to go up 2 and over 1. So that makes my slope 2x because I had to go up 2 and over 1. And this time it's a dotted line, so that's going to be important. So we'll find our double shaded region again. Up here it's double shaded, and if I look from my y-intercept, that double shaded region is up from there, which means again this was greater than, but it's just greater than this time because it's a dotted line. So make sure you pay attention to whether it's dotted or solid and write the correct symbol, and then it's just what we did before. Your slope was 2 because we went up 2 over 1. Your y-intercept was -3 because it was at -3. So let's do one more. Jamal makes $12 an hour mowing yards and $6 an hour raking leaves. He cannot work more than 15 hours a week. Write and graph the two inequalities Jamal can use to determine how many hours he needs to work at each job if he wants to earn at least $120 a week. Well, let's just start with his number of hours. Okay, mowing yards and raking leaves, and it cannot be more than 15 hours. That means if it cannot be more than, it has to be less than. And so since it can't be more than 15, we're going to assume it can be 15, so we're going to do less than or equal to 15. Okay? Now, we got to do the other one about the $120. I know that he makes $12 an hour mowing and $6 an hour raking, and he wants to make at least $120, which means that's the smallest amount he wants to make, so that's greater than or equal to $120. Now I have to graph these. Now if you will notice, okay, I'm going to deal with the graph. They have labeled for me. Hours mowing is on the X, hours raking is on the Y. So I'm going to rewrite these so that they are X's and Y's instead of M's and R's. So this becomes X plus Y is less than or equal to 15, and this is 12X plus 6Y is greater than or equal to 120. All I've done was turn those into the M's to X's and the R's to Y's so that I can deal with it. Now I need them to be in Y equals form. The first one's easy. You end up with y is less than or equal to -x because you'll have to subtract that x plus 15. Now the bottom one is going to take a little more work, and I'm going to try my best to explain a shortcut to you so that maybe you can pick this up and it can happen a lot faster. Okay, so to do this shortcut, this is what I usually do because I get tired of showing all the steps. I subtracted x, I divided by this, and I've been doing this a while. So it wouldn't hurt for you guys to pick up on this shortcut either. If you don't get my shortcut, you can solve this the long way and continue to do this, go step by step and get y by itself. But here is a shortcut. You know you're going to have to subtract 12x from both sides. And after you do that, you're also going to have to divide everything by 6. So I'm just going to do those two things at once. If I subtract 12, that makes -12, and then I have to divide by 6. Well, -12, so the opposite of this front number, -12 divided by 6 becomes -2x. So I've just done the opposite of the first number divided by the second number. So that gave me -2. Now, since I'm having to divide everything by 6, I also have to divide this 120 by 6. And since this 6 was positive, that's how I knew that this symbol was not going to turn the other direction. If it had been a minus sign in front of it, I'd be having to divide by a negative. I'd have to flip it, but it's positive, so I don't have to worry about it. So I have to do 120 divided by 6, which happens to be 20. So there's my equation. Now you can double check that by doing your algebra and going the long way, but here's how I shortcut it. Take the opposite of the first number divided by the second, and then I take the other number, my constant, by itself and divide by the y term. And that's how I get my equation. So we're going to graph this first one first. It's going to start at 15, and then my slope is -1, so down 1 over 1. I'm not even going to go into the negatives. I started to, and then I changed my mind. And the reason I'm not going to go into the negatives is because if you're talking about this, and you're talking about how much he works, he's not going to work negative hours. So they're all going to be positive. So here they are, and when I graph my line, it's going to be a solid line because that says or equal to. And I didn't use a very straight line, so I'm not sure that that's exactly where it ends, but that's close enough. And we've got a shade. It has to be less than that. So it's everything underneath here. Now let's graph the other one. So switch colors. I got to start this time at 20, and my slope is down 2 and over 1. And again, it's a solid line when I graph it, because it said or equal to, and now I have to shade everything above that line. So now I get to shade everything above it, and so the overlapping part is this triangle right here. They overlap in this triangle, and points on the boundary lines count for this because they are solid. So the next question is, if Jamal decides to mow for 11 hours, what's the maximum number of hours he could rake? Well, we're going to use our graph to answer that. So if he wants to mow for 11 hours is right here. The maximum number of hours he could rake is what falls inside this shaded region, in which I can count the boundary line, which is right here, which happens to be 4 hours. And so the maximum hours he could rake would be 4 hours. So he could mow for 11, rake for 4, and still be under his 15, and still make at least what he wants to. Remember, points on these boundary line counts because they're solid. Now the next one, if he decides to rake for 6 hours, what's the minimum of hours he needs to mow? Well, 6 hours is here. I go over, it meets the boundary line there, but if I go down, I'm not in the shaded region. So I need to go over a little more. I'm still in the shaded region here, but I'm not going to say that's probably, I apologize, right here, it meets the boundary line right here. And like I told you, boundary lines count. And it meets the boundary line at 7, so his minimum number of hours to mow would be 7 hours, because that's where the 6 meets the boundary line and the shaded region. And so that's your minimum mowing. I could have kept going and got my maximum, but they asked for the minimum. So there is how you answer those questions. It has to be a graph. You got to pay attention to whether it's a solid or a dotted line, and whether you shade above or below, and then look at where the shaded regions overlap. So we'll practice this tomorrow, and I will see you then.